All right, you guys, for those of you that came today, expecting an exam, we had moved it a couple weeks ago to next week. So congratulations, you got more time, to prep. Sorry if you didn't get the email or when I did the videos, I would remind it, so. But it's good to have new people here, I'll tell you. All right. We were letting off last time on how radio voltage joint contributes to our function, functional circles of reach and grip, and summating or canceling. And what we're going to do is we're going to use the upright row as an example to show how the radial ulnar joint is going to work with the shoulders to help keep our fingers underneath the bar when you're gripping and pulling up. To start off with, you are prone. Everybody agree with that I'm in a prone position? Okay. If I stay prone, I keep in mind too, the bar, I can't independently supinate from here. I'd have to split the bar in half. So in other words, if I just have supination by itself, it's not going to happen. However, if I bring the bar up and I'm moving elbows and shoulder, and I stay prone, now my thumb would be under the bar. If I stayed prone, if I understand that trick, that would be like saying this. If I stayed prone, this is what would happen. I take the spoon and flip it to the other side. So far, so good. So as I'm bringing my arms up, and I'm going to have some abduction and some external rotation, if I do not supinate at the same time, then I will not be able to keep my fingers under the ball. It's subtle, and you don't notice it because traditionally you're only taught about pronation and supination. It looks like it's moving, and it is, right? The easiest. But we have this radial ulnar joint motion that exists to help maintain our grip and position when we do non-traditional things. Let's use our thumb rule. See if we can figure out what happened. Start position, thumb is medial. In position, it's left. That makes sense? Now let me try to show you what's happening here. Let me see if I can do this. Let me see if I have the skills. Humerus, shoulder joint, radius wraps around the ulna. I'm going to start off being in a prone or wrapped position. Watch this. So what this is going to symbolize is what happens when we do this. It's unwrapped. Wrapped. Unwrapped. In other words, just like several other places in the body, most every place in the body, we can move one bone about another traditionally, but for the same change, we can move that bigger piece about the smaller piece. So in this case, we, instead of wrapping the radius about the ulna, we are literally unwrapping and wrapping the ulna about the radius. Because remember, I'm holding on to the bar, so I can't move it traditionally. I have to move it non-traditional. Does everybody see how that works? Take your hands, make sure they're prone. Bring them up, keep your fingers down, and notice how your thumb is now lateral to where you started. You see it? thumb rule. And again, that happens so that you can keep your grip under the bar. If you stayed prone and you brought your arms up, you would be here. Okay. Any questions before we move on? All right, last part, and then we'll do some practice, is our wrist joint. So the wrist is a biaxial, they call it an ellipsoid joint. An ellipsoid joint. It's made up of the distal radius and ulna and some carpal bones, scaphoid lunatum. Remember the wrist, let's see if you remember. It rhymes. The wrist doesn't twist. The wrist doesn't twist. So in other words, you can't take the wrist joint and spin it like this. We talked about why last class. You can do this, but that's radial ulna. Okay? Because the wrist doesn't twist, the thumb side, the lateral thumb side will always be radial side. The thumb will always be on the radial side and the pinky will always be on the ulna side. In other words, even when I pronate, thumb radial side, pinky ulna side. That's a big clue. It's a good hint for the motions that we have in our wrist, in the wrist frontal plane. So the ones you already know about: wrist flexion, wrist extension, flexion from, extension to, extension from, flexion to. And now we have frontal plane motion of the wrist. And frontal plane motion of the wrist are two different deviations. Pinky side deviation, or to the ulna, we call that ulna deviation, or thumb side deviation, to the thumb, to the radius, radial deviation. Ulna deviation, radial deviation. It's important to remember the pinky and the thumb rule for this one, because in anatomical, bilateral ulnar deviation looks like this. But I can pronate one arm and I can have them look like they're mirror effect, but they're not. I can have them go the same way, and they are. That's why it's important to be like, am I going pinky side or am I going thumb side? Pinky side, thumb side. 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 Ulna, deviation towards the ulna, which is always pinky. Radial deviation to the radius. Slide. How would then, for our upright row example, how could the wrist contribute to our functional circle? In this case, having ulna deviation to the ulna. Start, finish. You deviate ulna when, like, imagine you're lifting up something, let's say like some milk, and you bring it up, and ulna deviate to keep it level. Ulna deviation, a hammer, ulna deviation. So radial and ulna, frontal plane motions of the wrist. So on the test, I might ask, I'm not saying I will, but I could say, how many joint motions does the wrist allow for? And some students might say 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. This is not happening at the wrist. Get it? I could say, how many motions does the left elbow account for? Some students may say 1, 2, 3, 4. Let's make sure we know where those things are happening. Okay. Bless you, bless you, bless you, bless you, bless you. All right, guys. So before we get into practice, let's review our upper extremity motions. We have our scapulothoracic articulation, where we're going to have elevation, depression, protraction, retraction, upward and downward rotation. Function similarly to the pelvis to help get us a little bit more motion, but they're independent of each other, so they don't have to spin as one block. You can have independent spin of each scapula. Attached to the scapula is the humerus, glenohumeral joint, glenoid fossa, the humerus, that's our shoulder joint. All in socket has all the different motions of our hip that we've had before: flexion, extension, add, external, internal. We have the variation of horizontal ab and add. These are not the same motions, different motions. Right horizontal ab, left horizontal ad, horizontal ab, horizontal ab. Elbow, flexion, extension. Thing to keep in mind, I know I've said it before, but I love to teach with repetition. In anatomical position, some joints are at the end of their rope. The elbow, for example. So in other words, in anatomical position, my elbow is extended because that's as far as it could go down that road. So anything beyond is hyper excessive. But my shoulder isn't extended in anatomical. I could have extension from anatomical. My wrist isn't extended in anatomical. I could have extension from anatomical. The radial joint is supinated in anatomical, meaning it's all the way at the end of the road. It can't go any further. So fully pronated, fully supinated. But in anatomical position, you are supinated because you're all the way at the end of that road. Okay. So that's why certain joints, you could say, my knees are extended in anatomical because you can't go any further. And if you do go further, that's beyond on hyper excessive. So elbow flexion extension, radial ulna, pronation, supination, the act of going prone, the act of going supine. And then in our wrist, we have flexion extension about the wrist bilateral axis, and we have ulna and radial deviation about the wrist anterior posterior axis. So shoulder, all three, AP, ab and ad, bilateral flexion extension, polar, internal and external. Elbow, bilateral flexion extension. Radial ulna joint, polar pronation, supination. Wrist, bilateral for flexion extension, anterior posterior for ulna and radial. I said local landmarks save you from careless mistakes. So on the test, I might give you a deviation question of the wrist, but I might be pronated. And so by knowing the difference between a thumb and a pinky, you could be like, oh, this is what radial deviation might look like in anatomical, but I'm not in anatomical. Does that make sense? So I'm warning again. I play poker with my cards out. I'm telling you the kind of mistakes a lot of students will make. Just follow the fingers. Pinky side deviation is ulna side. Thumb side deviation is the radial side. Another common mistake that we've talked about in class is the shrugs. Right? That's not shoulder motion making you go up and down. That's scapular motion, and the shoulder's going along for the ride. Just like your elbows would be going along for the ride, your wrists would be going along for the ride. Everything attached is going along for the ride. It's scapular elevation and depression. For that to be shoulder elevation and depression, one, we don't have a term called shoulder elevation and depression, but literally you'd have to dislocate your shoulder and make it forward. This is the scapula going up and down, just going along for the ride. Any questions about the nuances of the motions? Fingers, I keep it simple because you do have a lot of nuances with interphalangeals. Flexion's going to get you in the fetal. Extension's going to get you out of it. And then in grad school, you'll learn some nuance about the thumb being a saddle joint and having ad stuff like this. Finger flexion, finger extension. It's important that I at least introduce you to finger flexion because finger flexion shows you the wrist flexion. Explain what I mean. If I'm in a different radial ulnar joint position, sometimes wrist motion might be confusing. So all you got to do is follow the fingers. Finger flexion, wrist flexion. Finger flexion, wrist flexion. The wrist flexion will always be in the same role as the fingers. So if you're ever lost, just follow the fingers and the fingers will show you the wrist flexion. Make sense? Okay. All right, let's do some practice. Okay, guys, let's talk position, and then we'll go change in position. So, from here we can do shoulder position, we can do wrist position, we could do radial ulnar joint position. I mean, we could do a lot of things, but remember, I'm only going to ask you obvious things. We could do ankle position. I think that's obvious. So one at a time, we analyze motion joint by joint. So look at the wrist, we'll analyze that position. Look at the radial ulnar joint, use your thumb rule to figure out that position. Let's do shoulder, and let's do ankle. That's right. Okay. Take a minute. Wrist, radial ulnar, shoulder, ankle. Position. Let's think of some other external examples. Things after a few minutes and things just something. Yeah. I got the brain fog today. I always love feedback. If you were on like on a game show and you could win a prize by being correct on one of those joint positions, where would you put your money on the one that you feel most confident? Like the shoulder? Awesome. Awesome. What about what's your second? Wrist? Wrist pretty good? All good feedback. All right, so good. Anybody need more time? It's such a catch-22. I want to give you more time, but I also want to give you more questions. And so it's always kind of one of those trade-offs. All right, the wrists. Are they flexed or extended? Good, good. They're in an extended position. It would be tough to do push-ups on the backs of your hands. Sounds like that sounds like a bad day, right? You know what's kind of neat? And again, sometimes I tell you these things not because I'm asking on a test, but I think it's neat enough where you'll just remember it. Your short bones, right? The torsals, your corporals are great at dissipating force. It's like landing on sand, right? You want to land on sand, you don't want to land on cement. And so one of the cool things that happens when we're throwing a punch is our corporal bones can kind of line up with our radius and ulna, and there's space in between those, and they help dissipate force. But another trick too is when we extend the wrist, we reposition the corporal bones to once again be put in a position to help dissipate force because they're like grains of sand. They can help absorb shock between what's pushing on us and the rest of the arm. So it's really kind of neat. So our wrists are extended, outstanding. Our elbows are anatomical or they are extended, same thing. Our shoulders are flexed. Cool. And our ankles are dorsiflex, outstanding. And again, I'm not disrespecting other things, it's just those what kind of stood out. Like her cervical's probably a little flexed, and you know, I don't want to get into little nitpicky things. I want to ask about obvious things. So correct, correct. So we could say there's certain joints that we could say the anatomical position is extended or supinated in the radial joints perspective because you're all waiting in the road. So you can't have extension from anatomical because the firming point of your ligament stop you there. So that's why like we can use terms like fully extended being the same as anatomical because those two are stop. Oh, I forgot about the radial ulnar joint. Is she prone or supine? Okay, let's look for clues. Is that her pinky or her thumb that we see in that picture? Pinky. So that means the thumb has to be on the inside, right? Yeah, so she's prone. Do you see how we can use landmarks? We can use clues that are on the person to figure this stuff out. Does that make sense? Another way to look at it too is her position for her arms, maybe not her, bless you. Her position for her arms is here. Like if I was on the ground, right? So I can literally replicate her position and be like, where am I at? I'm giving you some different tools to help you figure this out on the test, okay?
That last picture, we're about to scout the
Let's see. Oh, this if I would be very careful to ask the question. Her scapula would have protraction to help get her up. It would be protracted when she's up. It's not deviated enough in that one picture. Let me try to give an example. I didn't feel there was enough there to ask it with confidence. So so let's say she's going down and she does this, right? Like, so from here to there, I would feel more comfortable, but she looks pretty, like, it almost looks to me she could protract from there. Does that make sense? So that's why I left it off the table, because it wasn't like obvious. But for the down, so let's do that instead. Instead of going to a new one, let's do some motion practice. Okay, so let me do some clarification. For the shoulder, I would like sagittal contribution. We had mentioned this before when we went to shoulders. Sagittal, frontal, and then there's always some kind of combination. So when I say the sagittal component, that means I want whatever component of that shoulder is sagittal. Is it the flexion or the extension component? I don't want the ab or ad or the horizontal. If her elbows were a little wider, maybe we could do the horizontal ab and ad. But let's just have a conversation with okay, what's my next step, very well? It's not a senior teacher. All right, so we can have a wrist conversation, we can have an elbow conversation, we can have a shoulder conversation. And to separate it, guys, we're gonna go down, up, down, up, down, up. Motions at wrist, elbow, shoulder. And I feel okay about having scapular. We can do scapular. Our scapular picture. Some weird stuff happening at her feet. He's a wizard, Harry. Okay, so we're looking at changes in position, thus motion. Wrist, elbow, shoulder. First, flexion, extension, flexion, extension, flexion, extension, flexion, extension, flexion, extension, flexion, extension, questions, 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 questions. Good. Any questions on the wrist? Okay, you're not wrong. But that's a position. So the example I'll give you is if I always like to use road analogies, right? So if we're in Baton Rouge and we drive west and we stop in Brill Bridge, we're still east of Lafayette, but we travel west to get to that new position of still east. So in this case, that position, I'm extended 90, right? Roughly 90 degrees of extension. But in that position, I'm only extended 20, 30. So in other words, in order to go from this position of extension to that position of extension, amen, absolutely, I had to have flexion to be less extended, if that makes sense. A bigger example would be like if my shoulder was extended way back here, and I say start, finish, I'm still extended, but I had to have flexion to get to a less extended position, if that makes sense. Good question. Remember, there's no rule that says flexion has to get you to fetal. It's just getting you closer. You're getting closer than you were when you started. I'm closer to fetal here than I was there. That's why I had flexion. All right, elbows, flexion, extension, flexion, extension, flexion, extension. That should be pretty. You want me to ask 20 elbow questions, hopefully. Okay. We're good on that? All right. Let's go to the shoulder. Remember, I'm specifically telling you this is sagittal. We're having a sagittal conversation. Flexions and extensions. Extension, flexion, extension, flexion, extension, flexion, extension, flexion. Remember, this is shoulder. Flexion, extension, flexion. Cool? How will the scapula contribute? Retraction, protraction, retraction, protraction, retraction, protraction. Bless you. Cool? Let's do a lower extremity. Okay, guys, let's analyze some hips, some knees, and some ankles. And we'll go left to right, and then we'll come back right to left. Get some more practice. Hips, knees, and ankles. All right, hips from left to right, bilateral hip flexion, good. Knees left to right, bilateral knee flexion, good. Ankles left to right, bilateral ankle dorsiflexion, good. Coming back right to left, going back up, bilateral ankle plantar, bilateral knee extension, bilateral hip extension. All right, let's go to this visual that we've talked about before. I'm going to make this one open-ended. An open-ended question just means I'm going to move. You tell me anything and everything you saw that had significant motion. Okay. All right. Significant motion. Like if I twitch my knee or something, like don't count it. Start. Finish. Start. Finish. Start. Finish. Feel free to move about the country, you guys. I know it's shot. I know it, but just if it helps you, okay? If it helps you, please do it.
Uh,
With that. Well, that it's over there. I just moved it. I want you to tell me what you saw. In any place that had significant mushroom. All right, you guys, give me a joint that had significant motion. Don't tell me what it was. Let's just break it up into little pieces. What did you see that had motion? Scapula. Okay. How did the scapula move? Upward rotation, helping reposition my clock hand to get it over my head. Good. Elevation, maybe too, but remember on the test, I'm going to ask the elevation and depression when it serves a specific functional task by itself. When I'm going to ask upward and downward rotation, it's going to be specifically to help the clock hand as you try to bring your arms up, or sagittally or frontally. Okay. All right. So if the scapula upward rotated, it must have been working with the shoulder, right? So how did the shoulder move? Good. Don't confuse it with All right, what else did you see? What's that? What did my wrist do? Correct. You're good. This is what I'll end up just messing with. It's important. This is where we need to make those mistakes. This is where we need to say ankle inversion, right? This is where we need to say it because that's how often it's been etched in our brain. Absolutely. Radial ulnar joint. How did my radial ulnar joint move? How did my radial ulnar joint move? You got it. What's that? Yes, the thumb went medial. So what do we call that motion? The thumb goes medial. The act of going on your back or on your front. Prone supine. What do we call that motion? Going medial. Yes, Adam. I knew you had it because the improvement from that comments. I knew it's right there. Pronation, guys. Pronation. How do I know it's pronation? Thumb rule. You got to rely on these landmarks. My thumb starts off lateral, but it doesn't end lateral. My thumb is now medial. So whether or not you saw it, whether or not you sensed it, it doesn't matter. The only way my thumb's going to go from being lateral to being medial is if I'm gradually pronating as I go up so that I can keep the palm of my hand facing forward. Because if I stayed supinated, this is what you would see. Make sense? Good, good. Another thing too to work on the week and the weekend is get those names down. We have so many names that sound like we have a lot of different things that flex and extend, right? Abs and ads, and so make sure we study to get those things right, so they're not as confusing. All right, this is gonna be a fun one, I think. How about this? Here's my start position. Left on top of right. Yeah, I just want to make sure we did the same. Left on top of right. And from here, we do this. Right on top of left. So we're going left on top of right, right on top of left. Left on top of right, right on top of left. Was that? Oh, yeah. You tell me what you observe. Yeah. Now watch, I'm going to do it 10 times as fast as I can. You want to see that again? You want to see it again? That was pretty fast, huh? The dad joke, actually. Dad joke, ineffective. Try new tactic. Left over right, right over left. Open-ended question. Tell me what moved. We identify, we analyze joint by joint. So you pick a joint. This joint had motion. Great. What was the motion? And we also don't assume. It might be bilateral. It may not be bilateral. Maybe the left did something and the right did something else. We analyze it joint by joint. And we do not assume. Was that? That's how I'm trying to teach you. Absolutely. That's what I would do. Because change in position is mechanically the definition of motion. So if you know where you start and you know where you finish, the motion is inferred. You had to move that way. Yep. Maybe on Friday, we can do some pelvic girdle stuff, because that seems to be an area people need more practice on. And then over the weekend, please study and have some questions for me on Monday for going into our exam. Okay. All right, here we go. Let's analyze wrists first. What's the position of my left wrist when I start? Good. Does everybody see how my left wrist is flexed? Let's stay on the left wrist, joint by joint. What's the position of my left wrist now? Extended. So what I'm saying is that a lot of times, guys, in human movement, whether it's sports, whether it's rehab, whether it's activities of daily living, whether you're working for a business, analyzing ergonomics, sometimes these motions are really hard to see because they're not traditional. So we have to use the clues that we have to prove the motion had to happen based off of position change. Where are you at? Where did you go? How did you have to move to get there? So I started off with my left wrist being flexed. I ended with my left wrist being extended. The only way that can happen is to have left wrist extension. Make sense? Okay. Right wrist. Start off extended. Finished off flexed. The only way that can happen is to have flexion. So basically what happened is this. Okay. All right, wrists, check. How about radioulnar joint? Did they both do the same thing or did they do different things? Good, and we can prove that. My left radioulnar joint started off prone because my thumb is medial side, but my right started off supine, thumb lateral side. My right went to medial, so I had to have pronation, and my left went to lateral, so I had to have supination. See how that works? Using the clues that we have to prove motion had to happen, even though our eyes may not see it traditionally. All right, last one for the day so that we can practice our wrist. What if I take my cup of coffee and I bring it up like this? How could my wrist, if my wrist didn't allow to move in the frontal and I brought it up, I would pour it out the back. So my wrist can work with my elbow to keep something level or whatever grip I need to keep on. So as I bring it up, how would my wrist move to help me with this functional task? How would it deviate, radial or ulna? Is it pinky side or thumb side? Pinky side, so this would be ulna deviation. Ulna deviation. Radial, ulna, radial, ulna. Ooh. Any questions? If you've started studying already, great. If you haven't, you've got to get going, because if you wait until the end, I'm telling you, all these words are gonna get very confusing, okay? Y'all have a good one. See you Friday.